Hello there. My name is Ajiboye Isaac, and today we want to learn a very important topic in mathematics, and the topic is sword. Let's say it together, sword, right? So our learning objectives. At the end of the lesson, learners should be able to give examples of swords, state and apply the laws of swords, express swords in their basic forms, use the idea of similar swords to perform addition and subtraction of swords. Key vocabulary words: integers. Integers are numbers, positive and negative whole numbers. Okay? Integers are positive and negative whole number. For example, 1, -2, 3, 13, and so on are integers. And you can see that they are whole numbers. So if you sign a negative, if you sign a whole number, you get an integer, all right? So which can be positive or negative. Prime numbers. Prime numbers are numbers that can only be divided by 1 and itself. A prime number is a number that can only be divided by 1 and itself. For example, 2, 3, 5, 7, all right? Yes, sometimes we can have odd numbers to be prime numbers, but not all odd numbers are prime numbers. But there are some prime numbers that are odd numbers, okay? So it is very important that you bear in mind that not all odd numbers are prime numbers. For instance, 9 is odd number, but it is not a prime. So bear in mind. And also note that 1 is not a prime number. 1 is not a prime number. Okay? Next key vocabulary word is rational. Rational numbers are numbers that can be expressed as a fraction. Numbers that can be expressed as a fraction are referred to as rational numbers. That is in the form of A over B. For example, 3. 3 is 6 over 2. If you divide 6 by 2, you get 3. And so therefore, 3 can be expressed as a fraction. And therefore, 3 is a rational number. And so many other numbers like that. So we also have irrational numbers. Irrational numbers are numbers that cannot be exactly expressed as a fraction. For instance, the root of prime numbers cannot be exactly expressed as a fraction, because in some cases you have, a very long chain of decimals. So that makes it very difficult to express as a fraction. And those numbers or such numbers are referred to as irrational numbers. Sorts. Certain numbers can be expressed as ratio of two integers, that is, as P over Q, where P and Q are integers. Such numbers are called rational numbers. From our definition of key vocabulary words, we have already explained that. Some numbers, however, cannot be expressed as ratios of two integers. Such numbers are called irrational numbers. For example, the square root of prime numbers, square root of 2, square root of 3, square root of 5, and so on. Irrational numbers, which are roots of rational numbers, are called surds. Irrational numbers, which are roots of prime numbers, are called surds. So you may come across such numbers, and then want to learn how to handle, how to add, multiply, or use such numbers whenever you come across them in mathematical expression. It has a very wide range of applications, so you should learn how to handle them, how to multiply. So to do that, we have a guide to help us to multiply, to add, to do whatever we want to do with surd numbers. And this guide is what we refer to as the rules of surd. We refer to the guide as the rules of surd. There are guides aiding the operation of surds. These guides are referred to as rules of surd. Rule 1. The square root of the product of a number is equal to the product of the individual square roots. For instance, the square root of A times B is equal to the square root of a times the square root of b. The square root of a times b is equal to the square root of a times the square root of b. Example, the square root of 12. 12 can be splitted into multiplication of factors such as 4 and 3. So square root of 12 is the same thing as square root of 4 times 3. And therefore, it is equal to square root of 4 times square root of 3. And therefore, that will be equals to square root of 4 is 2. And so that will be 2 times square root of 3. So therefore, square root of 12 can be expressed as 2 root 3. Rule 2. Square root of a over b is equal to square root of a over square root of b. For example, square root of 36 over 25 is equal to square root of 36 over square root of 25. And square root of 36 is 6, and the square root of 25 is 5. So therefore, the square root of 36 over 25 is equal to the square root of 6, is equal to 6 over 5. Is equal to 6 over 5. So watch out for those rules so that when you come across such expression, you therefore know how to simplify. Rule 3. The square of a square root is equal to a. Even from our knowledge of indices, that square root is index of half. So if you multiply the index of half by the power of 2, you get 1. So square root of a square, the square of a square root is the number under the square root. Okay, for instance, the square root of 3 all square, that is, if you square the square root of 3, you get 3. Please watch out for such expression. I say that again. If you square the square root of 3, you get 3. Let's look at some basic forms of surds. Basic forms: if the rational number under the square root contains factors which is a square of a number, the surd can be reduced to simpler form. Such simpler form is referred to as basic form. I'll take that again. If the rational number under the square root contains factors which is a square of a number, the surd can therefore be reduced to simpler form. Such simpler form is referred to as basic form. For instance, or for example, express the square root of 162 in its basic form. Let me state clearly here that the first thing you need to equip yourself with in these basic forms is that you must know the perfect squares from 1 to 20, or the squares of numbers 1 to 20. For instance, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, square of 5 is 25, and so on till you get to 20. Once you know that very well, it becomes easier for you to express numbers under a square root as product of squares of numbers and other integers. So in this example, square root of 162, I know I can express 162 as 81 times 2. And 81 I know is the square of 9. So therefore, the square root of 81 will give me a whole number. So the square root of 162 is equal to the square root of 81 times 2. And from our law, the first rule that we looked at in the previous slide, we know that the square root of 81 times 2 will become the square root of 81 times the square root of 2. The square root of 81 is 9, but the square root of 2 is a surd. Okay, it can be expressed as a perfect number or as a fraction. Therefore, the square root of 162 will be equals to 9 root 2 in its basic form, in its simplest form. The square root of 162 in its simplest form is 9 root 2. However, the simplification of a surd to its basic form can be reversed, right? It can be reversed. That is, we also look at the third rule of surd, you see that if we square the entire basic form, we can get back the surd. For instance, 3 root 5 is equal to the square root of the square of 3, because the square and the square root will cancel out. So we just take the square root of the square of 3, therefore giving us square root of 9 times square root of 5. And therefore, according to rule 1, we can combine the two numbers under one square root, which will give us square root of 9 times 5. And 9 times 5 is 45. So that will give us square root of 45. That is, 3 root 5 is equivalent to square root of 45. Similar surds. Similar surds. These are surds which are multiples of the same surd. For instance, 3 root 2, 5 root 2, 7 root 2 are similar surd since they are all multiples of root 2. Since they are all multiples of surd 2. And so, the application of this similar surd is so that we can add and subtract surd. Okay? Two similar surd can be added or subtracted by considering their similarity in terms of the surd. In this case, they are treated in the same manner or in a similar manner or in a similar way to like terms. I will say that again. When you have similar surd, these similar surd are treated as like terms. Okay? For example, simplify root 20 plus surd 45 plus surd 125 minus 2 surd 80. So the first thing to do is to express those surd in their basic forms. All right, I'll look at 20. Can I divide 20 by any perfect square? For instance, 4. Yes. Oh, if I could do that, then I can say 20 square root of 20 is equal to square root of 4 times 5. And then, applying the first rule, I can split the square root to become square root of 4 times square root of 5. So therefore, square root of 20 is now equal to 2 root 5. Okay? I'll do the same thing for root 45, which will give me 3 root 5. And I'll do the same thing for root 125, which will definitely give me 5 root 5. If I do the same thing for 2 surd 80, 80 is 16 times 5. And why am I saying 16 times 5? That's not the only way I can get 80, of course. But I'm saying 16 times 5 because I know that 16 is a perfect square of 4. So that if I split it, I can have square root of 16 times square root of 5. And square root of 16 is 4. So I will have 2 root 80 to give me 8 root 5. That is, root 80 is 4 root 5. So 2 root 80 will become 2 times 4 root 5. And that will give us 8 root 5. Therefore, taking all these basic form, substituting all this basic form for their corresponding surd form, we therefore become square root of 20 plus square root of 45 plus square root of 125 minus 2 root 80 will give us 2 root 5. I've replaced root 20 plus 3 root 5. I've replaced root 45 plus 5 root 5. I've replaced root 125 minus 8 root 5. I have replaced 2 root 80. So I'll collect like terms because they are all similar surds in surd 5. They are all multiple surd of 5. All right. So if I bring out the root 5, then I will have 2 plus 3 plus 5 minus 8. All root all sort 5. Okay, so 2 plus 3 is 5, plus 5 is 10, minus 8 is 2. So my final answer is 2 root 5. So when the root 20 plus root 45 plus root 125 minus 2 root 80 is simplified, it will give us 2 root 5. This is classwork. Please make attempt of this classwork and forward your attempt to my WhatsApp number. I'll be more than willing to guide you, to assist you if you're stuck anywhere, if you get confused. And I'll be expecting your question alongside. All right? I'll be expecting your question alongside. You can make good use of this tool. All right? You can pause and listen to the explanation of the examples again. You can pause if I make a comment and it's not clear. You can pause and listen to it again for clarity and better understanding. All right. Make sure you understand the explanation of the examples clearly, and then make attempt of the classwork and forward your attempt to my WhatsApp number. Assignment. This assignment is due first thing tomorrow morning. So make effort to attempt the assignment and forward your attempt to my WhatsApp number. All right. I want to encourage you that if you follow the steps and the explanation of the example, then the classwork and the assignment should be very easy. Thank you, and I'll see you in our next lesson.